So what I was saying before when the audio was choppy was that this drag drop package is one, in my opinion, that shouldn't have to exist, but it does because of limitations and deficiencies in the standard, the DOM standard for drag and drop. There are two main limitations in that standard. The first is that you cannot programmatically, as a software developer, initiate a drag operation. And what I mean by that is that, let's say, I've got some complicated thing where I want the user to click on when they click on a particular item in the UI, and I want to make sure that the drag operation doesn't start until they move the mouse, let's call it 15 pixels outside of the boundary of the thing that they're clicking on. A prime example of this is in JupyterLab, the tab bar that we have, or I should say in Phosphor, with the dock panel. You can click on the tabs in the dock panel and move the mouse to drag them around and rearrange the tabs. But when you try to drag a tab out of the tab bar, that tab gets torn off and you go into a drag and drop operation. The standard that's defined for the built-in native drag and drop does not allow that to happen for a couple of reasons. One is that the only way a drag operation can be started is by setting the draggable attribute on a DOM node to true. And then when the user clicks on that node and immediately starts to drag the mouse, the native drag and drop events start firing. And so immediately you see that it's not possible to set some sort of drag threshold for when the drag actually is started. So the user, it basically starts immediately as soon as the user clicks the mouse and starts to drag it. Secondly, it's incompatible with handling mouse move events. So let's say, for example, I still wanted to try to have the user click on a node, and as they start dragging the mouse, move it, manually. And then once, for example, once they drag outside the tab bar threshold, maybe then I set the draggable attribute to true on the node or something like that. That doesn't work because as soon as you start handling mouse events yourself in the browser, it disables the drag and drop framework. So it's impossible with the standard APIs to both handle mouse events on a node while also handling the drag and drop APIs. So that necessitated us to implement our own drag and drop kind of package so that we could do the kinds of things that we want, where once I'm handling a mouse event on the native browser mouse events, and all of a sudden I want to switch into drag and drop mode, I'm able to do that because this drag and drop package that we have allows us to programmatically initiate a drag and drop operation rather than having it automatically started for us based on the user's interaction. So that's issue number one with the built-in drag and drop APIs. The second issue is that the data that you can store, the MIME data that you can store on the drag events, so the things, the data that you can transfer between objects in the application is severely limited, particularly on IE. I don't know what Edge does at the moment, but at the time when we built this, IE only allowed you to store plain text on a drag event. That was the only MIME type it would accept. There was only one. So if you wanted to have a drag and drop where, yes, there's a text representation of this drag and drop operation, but there's also a binary representation, which is actually potentially, the URL of the thing that you want to download, or actual binary data that you want to drop, or something else that you define, you couldn't do that with IE because you could only store one chunk of MIME data on the drag event. So that wouldn't work for us. We needed to store multiple things on the MIME data. In addition to that, we might wanted to let's say more or less abuse the system for when we're doing drag and drops within an application. We can actually store stuff that's not just text or not just bytes on the MIME data. We can store full-on JavaScript objects because we're dragging and dropping within the same application. That's not something you can do with the native APIs, but it's something that's extremely valuable when you're talking about implementing something like a dock panel where you're actually dragging and dropping widgets in the UI. So that's not, if you weren't able to store the objects on the drag event, you end up having to kind of create a registry where you put in your rich objects and then have a pointer to those things in a text form. It just kind of becomes a bit of a pain. And so that was enough of a limitation with the native APIs that prompted me to basically want to write this package. So the module I'm about to explain and the behavior that it provides is modeled very, very closely after the actual drag and drop standard that the browsers implement, modified just slightly to suit our needs. the modification is basically just what you can store in the MIME data. In terms of the actual processing model, I believe I followed this spec to the letter, insofar as it was possible to follow the spec to the letter. And if I haven't, and it's possible, I would consider that a bug. So anybody that wants to kind of understand what's going on here and why the logic is so convoluted, you can just look at the spec, because the logic of the spec is convoluted. So kind of there you go for that. But jumping right into the code, there's a couple of type aliases and a couple of interfaces and one class that you deal with for this public API. And we can see the dependencies of this module is just on core utils and disposable. So there's, again, it's, there's 0 external dependencies outside of the, the Phosphor namespace to use this module. It should run in any browser, including IE11. So IE11 and any of the evergreen browsers, this package should work just like the rest of Phosphor. But basically, we've got some type aliases to define what the drop actions are and what the supported actions are. And those two type aliases are actually consumed by this interface, which is the definition of our drag event, which actually extends the definition of a mouse event. And this is this interface is different than the interface that's defined by the standard, because the standard doesn't give us everything we need. And so the drag event interface is different, but the actual behavior of the drag and drop processing should be identical. So this interface should be fairly well documented in terms of when these things will be present, or when they'll be none, or what their values will be, and that sort of thing. And so the first property is the drop action, which is the drop action supported or taken by the drop target. And the note explains how this is used. At the start of each event, this value will be none. During a drag over event, the drop target must be set to this value. That's actually a typo. The drop target must set this value to one of the supported actions, or the drop event will not occur. So what does this mean? This means that you, as an author of a widget, or of a Phosphor widget, or not necessarily even a Phosphor widget, just any sort of DOM website that you're writing where you want to use this drag and drop interface, your target, which is your DOM node that wants to accept the drop event, will need to handle this p-drag over event. Now in the spec, this event name is just drag over. So event.type, or event name, whatever you want to call it, is just drag over. We prefix all of our custom events with p-, just like we prefix all of our CSS classes with p-. That's kind of like a namespace. This means Phosphor created this event not to be confused with the actual real DOM drag event. But your node, or the handler, event handler for your node, when you get a drag over, you need to set it to one of the supported actions. And the supported actions are defined by the, the code or the user that initiated the drag operation. When they initiate the drag operation, they're going to tell you, or tell the system, what actions they support, whether you can copy the target or copy the thing that's being transferred, whether you can move the thing that's being transferred, whether you can do both. So that's one of these supported actions. So you can either do nothing, you can copy it, you can create a link to it, you can move it, you can both copy and link, copy, move, link, move, or do all of those things. So that is defined, the supported actions are defined by the thing that starts the drag and gives the data to the drag and drop operation. The drop action is set by the consumer of the drag and drop operation. So this would be like, the consumer would be like the drop target. So let's say I'm moving a dock panel from one area to the next. The thing that I'm dropping on is the consumer, and that's the thing that's going to set the drop action. And basically, when handling the drop event, the target should set this to the action which was actually taken. And that has to be one of the supported actions, or the drop event will not occur. So this is something that's set by the handler that's consuming the drag and drop event. The supported actions, obviously these are read-only, so these are given in advance. I just mentioned that this is set when the drag is started. The proposed action is also set when the drag is started. Now this is just something that's a suggestion from the drag initiator, the code that started the drag and drop operation. They support all of the following that they indicate, but they say you should probably take this thing. It's just a hint. You don't have to do it, but this is what's probably best if it's known in advance what is best. The other thing that you get is the MIME data. So this is the stuff that's actually trying to be transferred around the app for the drag and drop operation. We covered this module. It's in core utils. So we covered this object when we went over that. You can go back and look at that video. It's basically just an ordered key value store of MIME types to data, and the data doesn't necessarily have to be binary or text. You can put rich objects in it as well. Finally, you have a source attribute, which is usually going to be null, but for advanced applications, the drag initiator may wish to expose a source object to the drop targets, and that could be extra context information. So if you have an advanced application and you need to know where the drag and drop action, where that thing actually initiated from, then you can provide a source object when you start the drag operation, and then any of the consumers can look back at that source object and do whatever they want with it. So this is basically just a way to pass around a little bit of extra metadata if you need it to have your application behave properly. And so this interface, this iDrag event, extends a mouse event, so you're going to get everything that you get on a mouse event, plus all of this stuff for all of the events that are sent to your nodes during a drag and drop operation. Okay, so that's the event interface, which is public. The only other public, I believe it's the only other thing that's public in this module. Let's go back and look. A few bit of static stuff, but yeah. So pretty much the only other public thing you're going to be dealing with is this drag class, which is the thing that actually instantiates a drag and drop operation and starts the drag and drop operation. So this is actually going to be created or instantiated by your own code in response to the user taking some event. So when we use the way that we use this in the doc panel module is that when the user is moving the tabs around or rearranging the tabs, we detect if the mouse cursor extends beyond the bounds of the tab bar by something like 10 pixels. I believe it's some settable threshold, maybe 10 or 20 pixels. And once the user's mouse cursor extends beyond that threshold, we tear off the tab and we create one of these drag objects and we start it. So that starts the drag and drop operation. So the constructor takes an options argument. So I'm going to go down and kind of go through what those options are. So some are required, some are optional. You must provide the MIME data. So this is the thing that you're actually trying to transfer using the drag and drop operation. So this needs to be created before you start the drag. And once you create it, you shouldn't really modify it. Technically, the interface of the class MIME data will allow you to modify it as needed. But the idea is that you just put your data that you want to transfer into it, and then you don't touch it after that. So that's required, and that's the only required argument to the drag object. Everything else has defaults. The drag image is if you want to have some kind of icon or something following the cursor as the user moves their cursor around during the drag and drop operation. Like let's say you're moving a file or something like that, and you want to have like some kind of file icon or whatever, you can do that. In the case of the tab bar, we actually provide an HTML element which looks exactly like the tab you were interacting with, and that follows the mouse cursor around. That's how that is provided. That's just simply an HTML element. If you don't provide anything, it's just null, and then all you get is the cursor shape for the particular drag operation that you're doing. So this can be any HTML element. So it can be as simple or as complicated as you want, which is quite useful. This is another thing that the native drag and drop APIs do not allow you to customize. You can't provide your own custom drag images. So it's very useful in a advanced application to have kind of richer visuals in terms of what you're dragging and dropping. And so this allows you to do that. You can provide the proposed action. So this basically gets copied right onto that event that we were talking about above. Also the supported actions, that gets copied again right to the event. And here's where you can provide the source context object if you want to provide one. So it's a pretty simple options object. So you basically create your MIME data and instantiate a drag class with that options object. And we see that if you don't provide a drag image, it's null by default. The default proposed action is copy, the default supported actions are all, and the default source is null. Excuse me. So all of that options data that you provided is also exposed on the drag object as read-only properties. So if you need to refer back to what you provided as options, you can. They're read-only. They don't change during operation or anything like that. So it's up to you whether you need to need to consult back to those or not. They're just there for convenience. The drag object itself is disposable, so you have your dispose method, which implements part of the interface, and you have your flag to test whether it is disposed or not. The only other public method that you deal with for the drag operation is starting it. And so this starts the drag operation, and you give the client X and the client Y position for the drag start. Now this is not exactly ideal. So the client X and client Y, this should be the current mouse position of the user cursor. The reason you have to provide it to me is because the browser has no way for you to query for it on demand. So the only way you can actually get the client X and the client Y position from the browser is in response to a mouse event that you've already kind of handled. There's nothing I can query in the browser to say what's the current mouse position. So you have to provide it for me. And so the idea is that you're always going to be starting a drag operation in response to some mouse event, which makes sense because it's drag and drop, not like key press and drop or something like that. So you should have a mouse position available for you, available to you at the time you create the drag or at the time you start the drag operation, at which point you need to provide it to me. And the thing that it returns to you is a promise which resolves to the particular drop action, which is the action that the drop action that was taken by the drop target after the drag has been finished. And so this promise will resolve, and it's either going to be none or it's going to be the thing that was actually done. And then you can do whatever you need to do to clean up in response to that drag and drop operation occurring. And obviously it's a promise because it has to be asynchronous. So now the interesting thing that happens here, between the time that you call start and the time that this promise returns, the Phosphorus drag and drop module takes complete control of the mouse and the keyboard for the entire browser because it has to, because it's actually managing all the mouse movements. It's having to manually synthesize and fire all those drag drop events. It's having to interpret key presses like escape to cancel the action and all that kind of stuff. So between calling start and the time that this promise returns, you can assume, assuming your application is not trying to do anything nefarious, you can assume that nothing is going to happen other than users' mouse movements and keyboard events, which are going to be acted upon in the context of this drag and drop event. So yes, this is asynchronous, but your application is going to act more in a synchronous fashion between calling start and actually having this promise resolved. You won't be able to handle, you won't get any of your own mouse events, you won't get any of your own key press events. Everything is trapped at the top level by this module. So when you call start, it's going to take, the browser, this module is going to take the client position. It's going to mount that drag image to the DOM. It's going to install all of its own event listeners to start trapping everything. It's going to initialize this promise to hand back to you, et cetera, et cetera. And then it's going to start handling all the events that it gets. So it handles all the mouse moves, all the mouse up events, all the key down events. It actually traps every single event that happens in the browser, and anything that's not a mouse move, a mouse up, or a key down just gets suppressed. So no other events can occur during the drag and drop operation. I don't know if you want me to go through all of the logic that happens during mouse up and mouse move and all of that. It's basically lots of convoluted logic that follows this processing model standard. So it's probably easier to just read this standard to understand what's going on, and then referring back to the module if you need to. Just in terms of documentation, the best way to describe it is that the events that you get and the processing model that occurs is the same as what's described here, except all the events are prefixed with P dash rather than reusing the native names.
Chris, quick question.
Yeah.
You hear me? So in some applications or OSs and things like that, you can start dragging and then press a modifier key to change the drag action. So you might press Control or Shift or something like that after you've started dragging to change it from a copy to a move, etc. Sounds like that's not possible here. And I think I remember when we looked at it before, it's not possible that basically everything needs to be, all the modifiers, whatever it is, the user intent needs to be discerned at the start of dragging and can't change during a drag. Is that right?
That's currently how the module behaves, yes. What you're describing could be implemented. I don't believe it's implemented in the native standard, which is probably why I didn't do it. I tried to follow that processing model pretty much to the T. But if we decide that that's something that we want, then we can decide to do it. I mean, it's our code, we own it. And there's nothing to prevent me from implementing that.
And that would just, like, your event handling here would just need to somehow be modified. I mean, is that the key sticker here, is that you're controlling all the events, so nobody sees any of these events, but that event handling logic that you just showed us could be changed to, like, capture shift or something like this?
Yes, exactly. Yeah, we could do that.
Okay.
Yeah, and it wouldn't even be that I would need to capture any additional events. It would just be on the mouse move. I would just be checking whether any modifiers are held and changing the proposed action appropriately. It would be a very simple update to change.
That makes sense. Or at least if it's a constrained thing, like if you just provide an interface for, you know, the action if shift is held, the action if control is held, et cetera, then you could take that. That's very constrained logic versus kind of opening it up to the user, right?
Yeah, that would probably be something we could do. We could change this to, we could add some additional options, and you could say like shift proposed action down here, that kind of stuff, like or control proposed, basically, you know, have some more options. Yeah, I mean, that would be easy to add if we need that behavior. I would just open a feature request.
Okay, thanks.
Yep. Any other questions on that? There's one more function. It's a static function in the drag namespace. So it's drag dot override cursor. And basically what this function does allows you to override the cursor shape for your browser to any particular cursor name that you want, and that what this cursor name is defined in the DOM standard. So there's, you know, a range of stuff that you can pick, like arrow left, arrow up, crosshairs, that, you know, whatever it is. It's all in the DOM3 spec of what cursor names that you can provide. And what this allows you to do is basically override the cursor for the entire browser to show that cursor, no matter where the user is hovering. So does my cursor actually show up on the screen share, or does it not?
Yes, it shows.
Yeah, we can.
Okay.
We can see
So if you see how right now my cursor is an arrow, like the pointer, and then when I hover over some text, it goes to that little I-beam caret kind of thing. So that's what I'm talking about when I talk about cursor shape. Now, sometimes you want to override this. For example, if I select some text and then I want to start drag and dropping it, I don't necessarily want the cursor to change as I'm hovering over different things in the browser. Maybe I do, maybe I don't. But sometimes I don't want it to change at all. And the way the browser behaves by default is it doesn't care what you're doing with the mouse, or whether buttons are pressed, or whether a drag and drop operation is in effect or not. Whatever the cursor is defined for the node that the mouse is hovering over, it's going to change to that shape. And that's sometimes not what you want. And so this override cursor function allows you to override that for the entire browser. And it uses some CSS magic to do that. And it returns to you a disposable. And when you dispose of it, it will basically revert it back to the plain cursor. And basically the way that this works, excuse me, is that the last person that overrides the cursor, this is the one that's responsible for disposing it. So you basically have a static ID that keeps getting incremented, and it sets the cursor for the document body, so it sets it for the whole body, and it adds this magic class to the DOM, and I'll show you what the CSS rule for that is. And then it returns to you a disposable, and when you dispose it, if you're the current owner of the cursor based on that monotonically increasing ID, then it clears the cursor and removes the class. And so just to show you what that CSS looks like, we have a little style package here, and there's just a very simple CSS rule that grabs that class when it's defined for the body, and it selects everything in the DOM. So this selector will select everything in the DOM when this override cursor class is present, and it forces you to inherit the class from the body, and it marks it as important. So unless you have a selector that's more specific than this, which you're going to have to, you know, work very hard to make a selector more specific than this, the cursor will basically be overridden. So that's what that little static function does. We use it internally in that drag and drop module to set the cursor to, you know, like the move crosshairs or the copy crosshairs or the, you know, whatever it is, or the link or whatever, depending on what action you're currently proposing or taking. We use it to override the cursor for that, but we also use it in other parts of Phosphor to set the cursor for certain actions when we're doing certain mouse drags and that kind of stuff. So you can use that as well in your own application if you need to. So any questions on that?
Could you show the events that will be given to a widget? Oh, they may be right there. So P drag over, P drag leave, P drop. Are those just the 3 events?
And then drag enter as well.
Oh, drag enter. Okay.
So enter, drag over, leave, and drop. So these are the same ones that are defined by the standard. It's just prefixed with P dash. So basically, if you go and you start reading this processing model, it kind of goes through what events, like you fired, drag start and then drag enter, drag leave, that kind of stuff. So it should be following this exactly, unless it's updated since I implemented this. I see we have, so we have drag enter and drag leave, and I guess they changed that to drag start and drag exit. So this spec has mutated out from under me since I implemented this, but yeah, that's basically the idea.
Cool. Okay, that answers my question.
Okay, cool.
Chris, can you comment on possible ways for you to maybe take advantage of native drag and drop, which has some things that you can't do with the Phosphor drag and drop, and the Phosphor, like, is there a way to use both of these together to complement each other, or do you really have to decide, and when do you have to decide which one you're using?
So if you're, so the things that are possible with the native APIs that are not possible with the Phosphor's API is dragging and dropping between the browser and the desktop, or between browser windows, or between the browser and other applications, because it's a native API and it's actually communicating with the operating system under the hood. Me as a JavaScript developer, I don't have access to those internal APIs with the operating system. So there's nothing that I can do to make this work, Phosphorus package work, to drag and drop between applications or between the browser and the desktop, for example. So that's the big limitation of Phosphorus package. If you're only doing drag and drop within your own application, so within your own browser tab, Phosphorus package, I would go out on a limb and say, is superior to the native APIs. You're not losing anything by doing that, by using Phosphorus package, as long as you're staying within the same browser tab. But you're gaining a lot of flexibility in terms of how you start your drag and the kinds of data that you can transfer between various objects in your application. Does that answer your question?
Right. Okay. Yes, that answers part of it. And then the other part is, if you want to use one or the other or both, like, in what ways can they work together, or if they can't, I mean.
Yeah, so they can work independent. They can both exist in the same application. They just can't work simultaneously. And simultaneously, I mean temporally simultaneously. So you can have both of them active on the same page. So you could have, for example, you could have a node in your application that accepts drops from the desktop. Let's say you're implementing a file manager, for example, in JupyterLab, and you want to accept drops from the desktop to upload stuff to your Jupyter backend. That's fine. You just handle your file manager needs to handle the native drag and drop events for that, which it can. It just listens for the native events. That same file manager can also handle Phosphorus events and be a drop target. It just listens for Phosphorus events. And since those events have different names, it's very easy to distinguish which one you're working with. Now, if you wanted to, let's say, do the inverse and have your file manager be able to drop from the file manager onto the user's desktop to do downloads, while also using Phosphorus package to drag and drop within the application, that's more difficult. And the reason that's more difficult is because in order to use Phosphorus package, you have to be listening to mouse events. And as I mentioned in the beginning, as soon as you start handling mouse events, the browser disables the drag and drop events. So you can't handle both of those at the same time. You kind of have to pick one or the other. If you're going to be a drag target or a drag start, like you're the thing that initiates the drag, you need to somehow distinguish between upfront whether it's going to be Phosphor initiating the drag or the browser initiating the drag. And it all has to do with that, draggable attribute that you have to tag on the node, and the fact that you can't get mouse events and also get drag and drop events.
Can you,
That's
for example,
of the browser.
Can you, for example, have a node that you can drag normally using the native API, and if you press Control, you could use the Phosphor API?
As far as I'm aware, no. I believe
Okay.
last time I tried that, and just the act of getting the mouse events to check whether Control is held or not prevents me from getting the drag events.
Okay.
Even if I don't stop propagation or disable the default event of the mouse event. And I don't know if that's part of the spec or not, but if I recall correctly, when I wrote this package, that simply listening for a mouse event on a particular node will prevent that node from using the native drag and drop APIs.
Okay, thanks.
Okay, so moving on to the next package, which is Virtual DOM. And this is probably going to either rub people the wrong way or explain a lot of things. So, Virtual DOM package. Why did I write a Virtual DOM when React exists? So, Phosphor, when we started Phosphor, it was a very long time ago. Geez, when was this? This was like at least 5 years ago now. Had to have been at least 5 years ago now. React was a very nascent technology to the point where it had just come out. It certainly didn't have the traction and community and following and refinement that it has now.
Or license.
Or license, yes. That was a big thing too. So back in the day, React had this poisonous patents clause in the React license, which basically prevented us from using it even if we wanted to use it. So, looking into React, I saw that it was a good idea for a limited set of use cases. There are certain things that are really difficult to do with a React app, like try making a doc panel with a React app. You're going to have a hard time. But that's the kind of applications we wanted to build with Phosphor. And so applying React to that would have just been, we would have been working against ourselves. So it's a very good technology for rendering what I would call leaf content. So basically not the infrastructure, not the scaffolding, but the nuts and bolts of your application, the stuff that you're actually wanting to present to the user, the leaf content, so the last stuff in the DOM chain. It's really, really good for rendering that. It's a great pattern. You have some data and you render it, and it does the diffing and updates and stuff for you automatically. That's a good pattern. It's efficient. It's really good for rendering leaf content. It's also not a very hard algorithm to implement yourself if you want to. So we did. So rather than try to fight around React's patents clause or take on some external dependency of an even lesser proven technology that was like a clone of React at the time or something like that, we just decided to not take on any external dependency and implement our own virtual DOM algorithm, a very, very simple one, because we didn't need a lot of the stuff that React gave you, like React's lifecycle events. We didn't need that because Phosphor has its own lifecycle events. You already get notified when you attach or detach a widget from the DOM in Phosphor. So we didn't need a lot of the stuff that React provided. Really, we didn't need its event system, for example, its synthetic event system, which I don't even know if it has anymore. If I recall correctly, they dropped that. But back at the beginning, they had their own synthetic event system. We didn't need that because we just handled DOM events ourselves. So really, all we wanted was the virtual DOM rendering and automatic diffing. And we wanted to use that in a type-safe way. This was also back in the day when TypeScript didn't have any support for JSX or any support for strong React typing or any of that. So you were basically forced, if you wanted to use React in a type-safe way at the time, you had to do it purely from the JavaScript interface, which was really ugly. It wasn't anywhere near as nice as using JSX or TSX. And that was basically the only way you could use React in a reasonable way from TypeScript. So rather than do that, we implemented our own small, very, very small, but very efficient virtual DOM. At the time that I wrote it, it was quite a bit faster, I believe an order of magnitude faster in terms of doing updates and rendering updates than React was. But it was also doing a lot less. So I'm not saying that I wrote code more efficiently than React. I'm just saying we didn't have to do as much So we can be quite a bit faster than React was. And we also picked an API, designed the API in a way that looked good from TypeScript. It's all type safe to begin with, and it also looks nice when you're writing just TypeScript syntax. So this doesn't use JSX, it doesn't use TSX, it's just regular old TypeScript syntax, but it's all type safe. So that's what this module is. I don't think I've updated it since we initially wrote it. There hasn't been any need to update it. We haven't really found any bugs in it. It works. It's a virtual DOM. We use it internally quite a bit in Phosphor for rendering leaf content. And by leaf content, so we use it to render the items in a menu, for example. We use it to render the tabs in a tab bar. We use it to render all of the items in a command palette. I'm wondering, do we use it anywhere else? There could be people, like third parties, that are using Phosphor that are using it because they're customizing the rendering of our command items or our menu items or our tab bars, that kind of stuff. And we have hooks in place to allow people to provide their own custom renderers to do their own custom rendering for that. So that's how we use the virtual DOM. We needed a virtual DOM, and we didn't want to take on an external dependency, so we wrote one. Again, this is nowhere near a competitor to React. It solved the problem that we had at the time. At this point, I would say that the patents clause has been solved with React, so it's no longer, they got rid of the patents clause, so now it's safe for everybody to use. It's come a long way since we originally wrote this module. TypeScript has first support for React now at this point, in a type-safe TSX form. Now Jupyter Lab is using it all over the place. So I would imagine that for Phosphor version 2.0, that will probably likely be the first external dependency we take on, and we'll get rid of this. We'll deprecate this core virtual DOM module and move over to using React for all of our Leaf virtual content rendering. So what does all this mean? This means that Phosphor is not competing with React. I want to say that again so it was clear on the recording. Phosphor is not competing with React. They're complementary technologies. So virtual DOM is really, really useful for rendering the Leaf content and the kind of applications that Phosphor is designed to build. It's not a good technology for building the overall scaffolding for the application, at least in our opinion, for the types of applications that I designed Phosphor to build. So you could think of Phosphor kind of sitting at a higher level with some higher level patterns than what React provides. Treat React as just a Leaf content renderer within Phosphor, and you'll get along great. So it's a good technology. We use it where it's applicable. I should say we will be using it where it's applicable in Phosphor 2.0. Jupyter Lab is already using it where it's applicable. But until then, until we release a Phosphor 2.0, this module exists and it will continue to exist. And if people find bugs, then I'll fix the bugs. But I would say that if you're starting a new Phosphor application, unless you're wanting to supply a custom renderer to change how Phosphor by default renders command palette items, menu items, or tabs, then you should be using React and TSX to render your Leaf content into Phosphor widgets. The only reason you should have to touch this module right now as a user is if you're wanting to customize how Phosphor itself renders some of those default items in the default widgets. And again, just know that in Phosphor 2.0, we're going to change how those default widget content is rendered to be using React as well. Okay, we can talk about title. This is pretty simple. Okay, so the title class is, I mentioned this way back when we were talking about attached properties and how the widget class uses an attached property to store a reference to a title object, because sometimes it's useful to store information related to a title for a widget, but not every widget is going to have a title. For example, some nested panel somewhere in your application probably isn't going to have a title. And so it doesn't need a title object created for it. And so rather than creating a title for every single widget that's out there, it's created on demand. Well, when I say title, this is the object that I'm talking about. So it's a generic class, generic on T, and T is just the owner, the thing that owns the title. So given a title object, you can always find out who owns it. And this is useful for the tab bar, for example, because the tab bar is rendered based entirely on titles. But sometimes when you're dragging around a tab, or if the tab title itself has changed and you get what the current title is, you want to track that back to actually who owns that tab or who's the owner of that title object, so you can update something else in your application. Having this back reference to the owner of the title helps you with that. So you don't have to actually keep your own mapping between, tabs and owners and all that kind of stuff. Once you have a title object, you know who owns it. So that's what the owner is for. Other than that, you instantiate a title object with a variety of options. So the title always has an owner. That's required. It can't be changed once it's set. You can optionally provide a bunch of metadata for the title. So you can provide a label. You can provide a mnemonic, which is the index for the title. So if you're going to use this title object, let's say in a menu item or something like that, you might want to underline a particular index in the label to show that that's the mnemonic for that thing. So again, it's just metadata. This particular property is deprecated. It's been renamed icon class to be more specific. So this is a class name that gets added to the node associated with the title, a label for that icon node, a caption for that. So if you want some hover text, again, this is all metadata. It's up to the UI to decide how they actually treat this data, but it's just some common metadata that's associated with all these things. A class name that's added to the node, whether the title should be closable. So let's say, so this closable flag controls whether you get the closing X mark on tabs in the tab bar or not, any data set you want associated with the node, et cetera. It's all basically metadata that's all UI centric. And you can provide all that stuff as options to the options object for the constructor. And you can also change it. So the title object is live and it has a change signal on it that parts of the UI can listen to. And so whenever you change one of these values in the title, that change signal is emitted, and the things that are rendering these titles in the UI will update in response to that. And I say will, like obviously the UI has to implement that logic. All of the logic within Phosphor that consumes the title objects does listen to this change signal and will update itself when you change the stuff in the title. So let's say you've got a tab bar displayed for a bunch of widgets, and you go to one of those widgets and you change the label for that widget's title. You don't have to do anything else. The tab's going to automatically update itself. So this is a canonical example of where you'd use a signal in an application. It's like, hey, I've changed some data. Anybody out there that's listening, you might need to update yourself. And that's exactly what the UI does when it consumes the signal. So that's the title class. It's used by widgets. And if you've used Phosphor for any length of time, you've probably come across it before. So very simple class, just a storage of metadata with the change signal so that the consumer knows when the metadata has changed.
And the data set there is just an arbitrary blob? Is that right?
No, it's defined as a data set, which is actually my definition. Sorry. Lost on me. So yeah, right here. So it's basically just a string map. So basically to key string map, it's the name of the string that you want. So these are all of these keys are going to be prefixed with like data hyphen whatever and added. The values will be added to the node. So this is actually the HTML element data set that gets set on the node.
Right. So the intention is that they're added, right? This module doesn't do any of the adding. It just carries the metadata. But
Exactly.
But the tab node, the intention is that the tab node will take all these key value pairs and put them as data elements on the DOM node.
Yes, and it actually does exactly that. Let's scroll down to the definition here. So if we look at the renderer, so this is in the tab bar module. So this is tabbar.renderer. It implements this iRenderer. So again, it's just an interface. We have a default implementation of it, which renders a tab using the virtual DOM. We'll get into this more when we start talking about more widgets, but just to talk about this. So we see that we have this create tab data set, and then it sets the data set on the virtual DOM, which will add all of those things as nodes or whatever. But this create tab data set thing here goes data.title.dataset. So it just returns data set defined on the title and adds that to the node for the tab.
You can also see all the way throughout this code base, it's using the data.title all over to set icon classes and all sorts of other stuff. Yeah.